right, so now we're down to our third section of the quiz review. And so we have 3 questions on the back side of the quiz on graphing functions and reading functions. So let's go ahead and go back into our whiteboard here. And to make things a little easier, I want to look at a graph. So I'm going to use this backdrop for us. Now, for question 8, it says to graph the function. First thing I want to do is I want to set it up like you have it on your quiz, hopefully as neatly as possible. And this is what you want to do when you're using the graphing calculator. Look at what the intervals are on the picture and then match your graph to that. On the x-axis, everything is counting by 2's. So all of these spaces out here, all right, you're going to go basically to a maximum, an x maximum of 8, and then an x minimum of -8, and your scale would be 2. And you can tell that because that's the number that's written right here on your graph. So then when you're going on the negative side, you know what to count by. All right, for the y-axis, this first part is at 20. That means you're counting by 20s. So up here, your y maximum is 80. And down here, your y minimum is -80. So that's going to help the accuracy of your graphs. If you lost any points because of accuracy, chances are it's because you're either rushing through your graph when you're copying it, or you're not paying attention to the intervals. So let's finish up the markings of that, and gives you a y scale of 20. So that's what you would type in on your window form on the calculator. Now it gives you 3 intercepts, so x minus 5, x plus 5, and x minus 1. So these are your intercepts. So we have +5, -5, and +1. So -5, well, if we have -2 here, this is -4, that means -5 is right about here. On the right-hand side, +1, halfway between 0 and 2, and +5, halfway between 4 and 6. So yes, I was looking for accuracy on that. Now to find the intercepts, I'm going to substitute in 0 for x, so that gives me -5 times +5 times -1, which gives me +25. So my intercept is going to be a +25. Well, if this is 40, halfway between is going to be 30, halfway between there is 25. So it's not exact, but it's a better estimate than just blindly putting some points down on the paper. So now I have 4 points, but I don't really know the twists and turns and where is it going in what direction and things like that. So I'm going to go ahead and figure out some points. So when I do that, we want to go ahead and use our graphing calculator, which I will borrow somebody who left theirs in class. Unfortunately, the name is getting kind of smudged, so I'm not really sure whose calculator this is, but thanks for leaving in class right now. So now what we want to do is we're going to figure out some points on the other sides. This is really more beneficial for students who are not using the graphing calculator function, but are graphing it by hand. Remember I told you, you graph the points that are in between the intercepts. So if I have my table, let's do a table of values over here. We have x and we have y. So I would go from -6, -5 of course is 0, we already know that. Then we have -4, -3, -2, -1, then 0, which was +25, we already knew that. Let's erase some things here so I have some space to work with. And then +1, which was 0, 2, 3, 4, 5, and 6. We graph all the points between our intercepts, and then we graph 1 on each side. That's why I have the -6 and the +6. All right, so just substituting this in, -6 minus 5 times -6 plus 5 times -6 minus 1. And this gives me negative 88. So that tells me my point's way down here somewhere for negative 6, just past 80, almost to that 90 point. All right, 5 is at 0, so chances are pretty good that we're going up to the positive y-axis. Let's figure out what negative 4 is. So negative 4 minus 5, negative 4 plus 5, and negative 4 minus 1. That equals positive 45. So negative 4 at 45, we're talking right about there. Next one, negative 3 minus 5, negative 3 plus 5, and negative 3 minus 1. The product of that is 64. So that's going to be approximately here. Negative 1, so negative 1 minus 5, negative 1 plus 5, negative 1 minus 1. Gives us 48. Now, oops, I skipped a spot there. I think my points are off a little bit. Did I do 2? I did do 2. Oh, we'll come back to 2. 48 for negative 1 gives us right about here, actually. So I'm not going to worry about 2 right now. I know that the graph is going up somewhere like this. I do want to figure out what positive 2 is. So 2 minus 5, 2 plus 5, 2 minus 1 gives me negative 21. So that would be right about here, just a little bit over the line. And then 3 minus 5, 3 plus 5, and 3 minus 1. This would give me negative 64. Nope, sorry, just kidding. Negative 32. So for positive 3, we're looking at about right about here. And then 4 minus 5, 4 plus 5, 4 minus 1 gives me negative 27. So right about here, I guess. So my graph came from this side, now I'm looping back around. And then you want to make this as steep as possible because positive 6 is actually a pretty big number. So again, I am looking for accuracy on the graphs. Also, your graphs continue on, so draw arrows after each one. Alright, next graph. This time was a little bit trickier. We had more solutions, and I think a number of you missed your solutions. I guess it helps if we have the proper background as well. Let's go ahead and put the proper one on there. And my lines didn't really line up, so I'm going to redo the lines. Oops, still not lining up all that well. Try and be as neat as possible. Helps when the graphs are written for you, like mine were. Okay, so our function x minus 1, x plus 2, and x minus 3. So you have 4 x's. That means you have 4x intercepts, which means this is a quartic function. Quartic meaning x to the 4th at some point. If you were to multiply all of this out, it would be x to the 4th. So we have 0 as one of our solutions. We have positive 1 as one of our solutions. Our interval is counting by 1s on the x-axis, but it's counting by 5s on the y-axis. So you've got to be a little bit careful there on your intervals. You have negative 2 as a solution and positive 3 as a solution. So when we graph this, we see that for positive 3, we have a value way up here somewhere. It was beyond our interval, but it gives me an idea of how steep it is. For negative 1, our solution was 8, so we're looking at a value approximately there. Normally, you wouldn't check a point between 0 and 1, except for the fact that there are two intercepts, one at 0 and one at 1. This is not going to be a straight line. That's a ridiculous looking graph. There is a curve somewhere. So you need to check 1/2. When you do that, you get a value of about 1.6, so let's say that's approximately there. And then for positive 3, we get -8 again. And then we have that was for positive 2. Positive 3 is at 0, and then positive 4, again, was way up there somewhere. So we're looking for our steep graphs kind of going down, around, up a little bit, around, and then up again. It's a quartic function, even, so that tells us the end behaviors, both directions point in the same direction, and because our coefficient is positive, all the x's are positive, it tells me as x gets bigger, then f of x is going to also get bigger. All right, and now for our last question, bring back up a graph here. This time the graph was given to you, and you had to interpret some behavior from it. All right, not the neatest of graphs, I apologize for that, but we are running short on time, and I want to make sure this gets in under 15 minutes. We're asked to find the local maximum, we're asked to find the local minimum, and we're asked to find the zeros and what degree this is. Well, the zeros are probably the easiest to identify at first, and it's a little bit hard to tell on this graph on the screen, but you can look at your paper to tell. The zeros are where does it intercept the x-axis. So on your paper, you're counting by 2s. It does, again, this is a terrible graph, but this is -2, this was 1, and this was positive 3. So your zeros are -2, 1, and 3. You have 3 zeros, so that means this is the 3rd degree. Now, most of you recognize that this point here was your maximum, but it says to identify the coordinates. And so approximately, this is -1, 8. Now, normally, again, the maximum is just the y-coordinate. If you put the entire coordinates, if you put the pair, the ordered pair, I did accept that. And over here, most of you recognize that this was the minimum, which was at 2, -4, so the local minimum is -4. This is the ideal answer. If you gave me something close to it, I did accept it. I was pretty lenient on it. But I don't want you writing on the graph. Bring all of your information over to the side. Also, don't skip these questions. Most of you who got this problem wrong, it's because you skipped it. You didn't even try the problem. Try every problem. You'll at least get some sort of partial credit if you start off on the right track. And who knows, you may actually find you know more than you thought you did. So that's it for your answer key. If you have any questions, you can always come see me before the test. And the retake, for those who qualify for the quiz retake, will be on Wednesday during study hall.